Today we are going to be talking basically an introduction to trigonometry. We're going to introduce a few more ratios than what you're probably accustomed to. So let's take a look at this triangle over here on to the right. If you notice, we've got a 90-degree angle right there, so it's going to be a right triangle. And we've got a leg and a leg, and then we have the hypotenuse. Okay, remember the hypotenuse is always going to be opposite that 90-degree angle. So what we're going to do is take a look at some of these ratios here. It says we're going to define each trig ratio. And so we have sine, and then always, it's going to be sine, cosine, or tangent. And the argument is always going to be an angle. All right, so this is always going to represent an angle. So we've got theta. We can have x. We could have whatever variable, whatever symbol we want. It's always going to represent an angle. So sine of theta, so what we're going to do is make sure we understand the ratio. We've got opposite leg over hypotenuse, right? So let's just remember, maybe you've heard of SOHCAHTOA. And the S is for sine, right? So we've got our sine. And then the O and the H give us the opposite over hypotenuse, right? And then we've got cosine, which is going to be the cut, which is adjacent and hypotenuse. So adjacent, I want you to make sure that you understand that's two things. It's the one touching. So it's the side touching, but not the hypotenuse. Okay, so be careful with that. And then we've also got tangent. And so we've got tangent, which is the opposite leg over the adjacent leg. So let's take a look over here. What we're going to do is look at the ratio for sine of A. So that means, again, the angle A is right here. So I'm looking here in terms of this angle right here. We've got the opposite leg. Opposite means it's not touching. It's not going to touch the angle, not touching the angle. Okay, so that means this side is touching the angle and the hypotenuse is touching the angle. So the one that's opposite that is going to be this leg right here. And we're going to call that leg CB. Okay. Then the hypotenuse is right over here, and we're going to call that AB. All right. So that's why we have CB over AB. And then what is new to you guys are the reciprocals of these. All right. So we're going to talk about that in just a moment. All right. So let's do sine, cosine, and tangent first. There are 6 trig functions. You are already aware of the first 3, sine, cosine, and tangent. So let's take a look at cosine of angle A. So if I were to look at cosine of angle A, remember it's the adjacent leg, but not the hypotenuse. So that means it's going to be this leg right here. It's the adjacent leg over the hypotenuse. So we have AC over AB. And then tangent of angle A, again, we're referencing our angle A, is going to be the opposite, which says it's not touching. So that's going to be that leg, which is CB, over the adjacent. Now remember, the adjacent is the one touching, but not the hypotenuse. So the one touching, but not the hypotenuse is that one right there. So we have CB over AC. So what's new now for you guys is going to be the reciprocal of each of those trig functions. So the reciprocal of cosine is secant. And we have the abbreviation secant theta, and all it is the reciprocal. So the reciprocal of sine is cosecant, and it's abbreviated CSC. And then we have the reciprocal of tangent, which is going to be cotangent, and it's abbreviated COT for cotangent. Okay, so let's go ahead and finish finding the ratios now of this second column. So let's take a look at sine of B. So if I've got angle B now, Sine of B is going to be the opposite, which means it's not touching. Remember, what are the ones that are touching this angle? You're looking at the sides that make up the angle. What makes up the angle is this side and this side. So the opposite one is going to be AC. All right. And then, of course, you have the hypotenuse, and the hypotenuse is AB. All right. So now let's take a look at cosine of B. Cosine of B, again, our angle is here. It says adjacent, which is not the hypotenuse. So this would be the adjacent one over the hypotenuse. So we've got CB over AB. And then, of course, tangent. Tangent says it's opposite and then adjacent. So we have got AC over CB. All right, so now let's go ahead and look at the reciprocals. So the reciprocal of sine is going to be cosecant. It's of the same angle, so you just flip. So instead of CB over AB, it's going to be AB over CB. All right, so we are just flipping those, and it gives us that reciprocal. So cosine of A, the reciprocal is secant, and again, we're just going to flip. Okay, tangent, the reciprocal is cotangent. Again, the angles have to be the same, and then you just flip. All right, so let's take a look at sine of B. We already had cosecant of B. We're just flipping secant B and then cotangent B. Okay, so those are the 6 trig ratios. And let's take a look at some of the other properties right here. Angles A and B, when you add them together, they're going to be 90, right? Because in a triangle, you've got 90 degree and a right angle. That means this angle plus this angle is going to be 90 degrees. So what vocabulary word means when angles add up to two angles add up to 90 degrees? That is going to be complementary. So again, we want to make sure we understand complementary angles. So what do you notice about the values of the sine and cosine ratios for two complementary angles? And so what that means is if you were to add up the value of the ratios, sine A is equal to cosine of B. So let's take a look at that. So if we were to look at these ratios over here, sine of A, is that the same thing as cosine of B? And if you look at that, we see that. So sine of A is going to be the same ratio as cosine of the other complementary angle. All right, so what if I had cosine of A? Cosine of A is going to be the same thing as sine of the other complementary angle. All right, so if you need to process that, I recommend that you just take a moment and make sense of that. Using trig ratios to find missing side lengths, we're going to complete the following table. So it says if CB is equal to 5. So the first thing you need to do is understand CB is 5. So I'm going to put 5, okay? And it does say that this is a 45-degree angle. Well, if B is a 45-degree angle, we also know that A is a 45-degree angle because they have to add to 90. And if these two angles are the same, then that means the sides opposite them are the same. And if CB is 5, then that means AC is 5. So you need to always mark up everything that you know based on the given information. So we are asked to find the length of AC. So what we are trying to find was this AC. Now, again, we should already know that the length of AC is 5, but let's just go through the ratio. So if you only marked up 45 degrees because it was given, and this is 5, then the only thing, and we didn't know what this was, right? So this was a question mark. So we didn't know, let's pretend we didn't know. Then that means we would have to use the tangent ratio because we're looking for the opposite leg, right? So we're looking for the opposite leg and we know the adjacent. So tangent of 45 degrees is equal to the length of the opposite leg over the adjacent. And then we're going to multiply both sides by 5. And in your calculator, this is always a good way to check your calculator, you need to be in degree mode. And then if you were to evaluate tangent of 45 degrees, you're going to get, you should get 1. So tangent of 45 degrees should be a 1. So double check that in your calculator. And we know that AC is 5. Okay. Now, using those other skills that you've learned in previous geometry lessons, you should already be able to conclude that AC was 5. Now, AC is 5. It says find the length of AB. Well, AB is right here. It's that hypotenuse. So you could use any ratio as long as you are able to complete it. So we could use cosine. We could have used cosine because we had the given information. Personally, that's what I would have used because you always want to stick with the given information, but it'll still work out. So sine of 45 degrees. So what he's having us do, if we look at this, we've got the 45 degrees here. And so the opposite, which is 5 over the hypotenuse, right? So 5 over AB. Now we're trying to solve for AB. So we're going to multiply both sides by AB. And then we're going to do that to the right side. So AB times sine of 45 is equal to 5. Remember that sine of 45 degrees is a number. So that means we're going to have to divide by sine of 45 degrees. So AB is 5 divided by sine 45. When you put this into your calculator, you got to be very careful and you should get that approximation. All right, so now it says, well, multiply CB. All right, so CB is 5. So we're going to take 5 by rad 2. So in your calculators, we are going to go 5 times rad 2, and then you get the same number. So hopefully you're recognizing that rad 2 is a specific value. When you multiply it by 5, that's what you get. So I would like you to try these. We are given AC is 5, so that's marked up right here. Find the length of CB. So you are asked to find the length of CB. So again, this was given. We know that this would have to be 60 because the other two angles add up to 90. Always try to stick with the given information. So 30 was given. So we're going to start off with tangent, which is opposite over adjacent. We're going to multiply both sides by CB. All right, we're going to multiply both sides by CB. We're going to divide by tangent of 30. Remember, that's a number, right? So we're going to divide that. And then in your calculator, that's your approximation. Okay, and then it says if AC is 5, find the length of AB. Well, AB is the hypotenuse. So we could go sine of 30. We know that this is 5 and where this is the hypotenuse. And then we could write down 8.660 here. But we also know that this is 5. So it depends on how you want to view it. There's more than one way to do things. Multiply both sides by AB, divide, and we get AB is 10. Okay, so this is 10 right here. Now, it says multiply AC by rad 3. Okay, so AC, all right, by rad 3. So if we get AC, we know that that is 5. Rad 3, and it's the same that we got for this guy right here. So this is the approximate value, or the exact value would be 5 rad 3. And then it says multiply AC by 2. Well, you got AC by 2, then that means you end up getting 10. All right, so if we take a look at the table that we had in the previous page, this table right here, we want to be able to establish some relationships based on certain types of triangles. So if we were to take a look at these two special rights, one's a 45, 45, 90, and the other one is a 30, 60, 90. Well, there are certain relationships that work with those specific types of triangles. And so that's what we're going to do right now. We should have already recognize some of these traits, but this should really be kind of like a recall session for you, except for adding in those 3 reciprocal properties. So let's take a look on a 45, 45, 90. We have what is called an isosceles right triangle. In other words, 2 sides are the same. So one of the things that we have is that the lengths of the 2 legs opposite the 45-degree angles are congruent. All right. So we have, again, the 2 legs opposite the 45-degree angles are congruent. So just like these angles are congruent, then we know that if I take a look at this and redo the marking up, this angle and this angle are congruent, then that means the sides opposite those are also congruent. All right. Then it says the length of the hypotenuse is the length of the leg multiplied by rad 2. All right. So this is what the diagram is going to show, right? So we've got a triangle, a right triangle, that's 45 degrees, 45 degrees. Then we have, let's say that this is x, then the hypotenuse is x rad 2. All right. So then the other idea is 30, 60, 90, which says, hey, that's a scalene right triangle, which means no sides are the same. So all sides are different. Okay. So I've got a right triangle. I got 30 degrees. I've got 60 degrees. And so there's a couple of properties that exist here. The length of the hypotenuse is twice the length of the shorter leg. So if this is the shorter angle, this is S for the short leg, right? It's opposite. Then that means the hypotenuse is 2 times the short leg, right? Then the length of the longer leg, which would be opposite the 60 degrees, is going to be the length of the shorter leg, which is S, the shorter leg times rad 3. Okay. And so that's what this diagram is implying. Okay. So if we know those properties, we can solve these 2 types of triangles without a calculator. If it involves other degree angles, we need a calculator. So let's take a look at this. If it says to solve a triangle, then that means we find all of the sides and all of the angles, all right? And we are going to use the trig ratios to find them. So let's take a look. It says AC is 11, so we're going to mark up our diagram, and CB is 16. So we always mark up what we don't know. Now, we have lots of ways to get to finding the missing sides and stuff like that. We could definitely use Pythagorean theorem to find the missing side, but they did say they want us to use the trig ratios. So that's what we need to do in order to follow the directions. So let's look at the measure of angle B. So if I have the measure of angle B, which is right here, I know opposite and adjacent. Okay, so I know those 2 sides. So that means I am going to use tangent. Okay, so let me back up here. So tangent of B is 11 over 16. And when you are trying to find the angle, then what that means is you have to undo, you have to take the inverse. So tangent inverse to both sides. So tangent inverse. But remember, tangent inverse, this becomes the argument of tangent inverse. So it's 11 over 16. So you have to put this into your calculator. And when you put that into your calculator, you're going to get 34.509. So that's where we're getting the measure of angle B. So now what we want to do is find the measure of angle A. And so again, what we know from angle A, you always want to use what you know. So I know what I'm given is opposite over adjacent. So opposite over adjacent. So that's going to represent tangent as well. So tangent of A is equal to 16 over 11. You take the inverse, and again, this should be review for you. Tangent inverse of both sides so that tangent inverse and tangent cancel, and we're left with A. And then put that into your calculator, make sure you're into degree mode, and then that's where you're going to get the other angle. Now, the only other thing that we are missing is the hypotenuse, all right? So let's just make sure we go ahead and mark up now what we know, and then we're going to find AB. Well, again, what you're going to do is use a trig ratio. So once you've found pretty much everything else, it depends on what you personally want to use for your trig ratio. So let's go ahead and do sine of this angle right here. So sine of A, so sine of that degree is equal to opposite over hypotenuse, okay? And that shouldn't be 11 sine of, oh, I'm on the wrong angle. My apologies. So sine of this angle right here, we're doing sine of B. So 34,509 is equal to opposite over hypotenuse. And that's what it is that we're trying to find. And so again, what we would need to do to solve for AB is multiply both sides by AB. And then we're going to divide by sine of 34.509 to both sides. So this is the exact value. So AB, we would box this for the exact value or put it in our calculator and round. Okay. And so then we found all three sides. We had the two sides and an angle, and then we found the missing pieces. All right, so let's try this one now. So again, mark up what you know. Measure of angle A is 43, CB is 12.5. So let's go ahead and analyze what we're given. So we're given an angle and the side opposite. So I could definitely find, using that, the hypotenuse, and I can also use the adjacent. So let's take a look at tangent of 43. So that's going to be opposite over adjacent. And then now what we're going to do is multiply both sides by AC. And then we're going to divide by tangent of 43. And then you put that into your calculator. And then now we get to mark up our diagram. Now we need to couple of ways to find the missing angle, but again, the directions said use the trig ratio. So let's take a look at tangent of B because we're trying to find the angle, and that is opposite over adjacent. So the 13.405 over 12.5. Remember, you have to do the inverse because you've got to get that argument out. So the only way to get B by itself is to take the inverse. So put that in your calculator, and then you end up finding that B is 47.001 degrees. So then from here, we found out that the measure of angle B is 47 degrees. We found out that AC was 13.405. Now let's take a look at the hypotenuse. So you could use any trig ratio that will get you there. Let's go ahead and use cosine of 43 degrees. You should really always use the given information whenever possible. So cosine of 43 degrees, personally, I would have used sine. So we could use sine of 43 degrees is equal to 12.5 over AB. And then they are doing cosine. And so when they do that, I'm going to get AB is equal to 12.5 over sine of 43. And no matter what, we should come up with the same number. Okay. And that is it. We are going to disregard the last 2 pages.